The first thing that we need to do is we need to highlight the givens. So we're gonna work in the first step, that is organizing the data. Okay? This is going to be the first step. So the problem gives us several information. Okay, it tells you that it's a concave mirror. Okay, and it's telling you that it has a focal length of 10 centimeters. It's asking you to locate the image. The object is a pencil, and this object is placed upright 30 centimeters from the mirror. So the pencil, which is the object, is placed upright 30 centimeters from the mirror. They are also asking you to find the magnification of the image and to draw a ray diagram. So now we need to just organize the data. They are giving us focal length that is 10 centimeters. They are telling you to find the image of a pencil. Means that I need to look for the image, the Q, okay? The reflection of the object. The object is P. Remember this. Object P. The image is Q. Okay? Both lowercase. Now, they are telling you also that the pencil is placed upright 30 centimeters from the mirror. So the object, which is the pencil, is placed 30 centimeters away from the mirror. And they're also asking you to find the magnification. That is the first part, organizing the data and actually gather information from the word problem. In the second step, what we do is we need to use the mirror equation. We need to use the mirror equation to find what the exercise asks you to. Okay? In this case, we need to find Q. So the mirror equation states the following: 1 over the focal is equal to 1 over the object plus 1 over the image. We need to isolate for the image. So 1 over Q, the image, is going to be equal to 1 over the focal length minus 1 over the object. This is the equation that we're going to be using. Now, we start working with it and we say 1 over Q equals, and now take a look to this, because this exercise asks me to draw ray diagrams. To do a sketch of ray diagrams, we need to use units. Okay, the ruler that you have is probably in centimeters. So for this exercise, I really don't care if you write the answer in meters. Why? Because your ruler, the ruler that you're gonna be using to sketch this problem, is gonna give you centimeters. Okay, so I won't be working with meters in this problem. So we say 1 over the focal length minus 1 over P. P is my object, and my object is placed 30 centimeters away from the mirror. So 1 over f is 1 over 10 minus 1 over p, that is 1 over 30 centimeters. It's not updated very often. Okay, so in the calculator, we're going to focus on the subtraction. 1 over 10 minus 1 over 30. How much does it give you? How much does it give you?
0.0607.
Okay, press this key. Well, wait a second. Wait a second. So, how I do it? I use this key, okay, or this other key. If you have the Casio, okay, I'm gonna use this key. So, it's going to be 1 over 10 minus 1 over 30. This should give you an answer in fractions.
1 over 15.
1 over 15. This is so slow. Oh my god. If this continues like this, I won't be able to teach this topic properly. Let me see. Okay, you said 1 over 15. Now, if you have this kind of calculator, it's the same. 1 over 10 minus 1 over 30 equal. Gives me 1 over 15. This is very important, okay, because this may change the answer a little bit. So in the end, what I have is 1 over 15 centimeters. What I do is to switch the position of them, I use the reciprocal function. So in the end, what I'm going to have is q over 1, q over 1 equals 15 over 1 centimeters. Okay, I'm using the reciprocal function. In the end, what I do is everything changes the position. What you had in the numerator now is in the denominator. And you know that what we do in the end, we ignore 1 as a denominator. Once you ignore the 1 you have your final answer, that is 15 centimeters equals Q. The image is placed 15 centimeters away from the mirror. Away, not away. That is important, okay? That you understand what is the meaning of it. And then in the third step, what we do is we calculate the magnification. Okay? For the magnification, we have this equation. M equals negative Q over P. Okay, that is the main equation. Now, we substitute by the givens that we have, and we are going to get negative 15 centimeters divided by 30 centimeters. You cancel centimeters with centimeters, and this gives you negative 1/2, also in a decimal like negative 0.5. Now this answer of negative 0.5 tells you different things. First of all, we look at the sign, and you need to classify the image. The sign, you look for the sign right here, okay, in this table. So a negative sign in M in magnification says, or tells you that image is real and inverted. And magnification, because it's equal to 0.5, 0.5 is less than 1. And remember what I told you in the presentation of this topic. When you have a magnification less than 1, means that the object's image is smaller, or that is being reduced. The projection, the image, the reflection is going to be smaller than the real object. That's what it means. Once you understand the two answers that you got, we can go into the drawing part, into the sketching part. And here I need your full attention. This topic I already explained you in a video, remember this. But what I'm about to teach you is different. So you're going to be using, for this topic, you're going to be using these tables. Okay, you're going to consider the situation that you have here in this exercise. But first, we need to start drawing. Okay, we're talking about a pencil. Remember, the exercise tells you that you have a pencil that is placed upright. And this is very important. The reason is, this tells you about the condition, the initial condition of the object. Okay, so you start sketching the problem, you start sketching it. What I do in the first place, I draw a horizontal line. Okay, wait a second. This should be larger. Okay, now with a compass, I don't know if it's well said compass, pero ustedes con un compasito, you're gonna do something. Okay, what I did over there is, well, it's the mirror, okay? All I did was the mirror. Remember that these kind of mirrors are curved, which means that it has a portion of a sphere. Now, it is important that you know a few things before drawing, okay? First, you need to know that C is the center of the circle that makes up the mirror, okay? C is the center of curvature, and C is equal to twice the focal length. The focal length is given in this problem as 10 centimeters. So 2 times 10 centimeters gives you 20 centimeters. So this is the radius that you should use with the compass. Bueno, pero compass es, I don't know if it works the same way. Compás es en español, eh, compass sé que es brújula, but I don't know if it works for the same object. The thing is that you need to draw a circle which has a radius of 20 centimeters. But I cannot use that amount of centimeters in your notebook because your notebook is not too large, okay? So what I do is I use a reference. That reference I call it scale. And the scale is for drawing objects, okay? To represent objects with a different size. For example, I can say that 1 square from your notebook is equal to 2 centimeters. Even if it's not true, I can use that as a scale. And that's the scale I use, okay? That's the scale I use. 1 square equals 2 centimeters. So, if I have 20 squares, that means 40 centimeters. So I need to locate my C, okay? That is 20 centimeters. 20 centimeters, it's going to be how many boxes, how many squares? For C, it's going to be 20 centimeters times. I want to know the number of boxes that I need to use, okay? You have the conversion factor that 1 square box is equal to 2 centimeters. And this gives you 10 centimeters. I mean 10 boxes, 10 squares. So you start counting from the position of your mirror. Your mirror is located here in this point, okay? So this is your first box, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. In this box, in this point, is where the point C is going to be located. Remember, C is the center of curvature. Once I have it, I can get rid of this. So I don't need it anymore. Okay? But what I do need is I need to indicate my size. Okay? This is 20 centimeters. That is the first point I placed. The second point I need is the focal length. The focal length given in the problem is 10 centimeters. How many boxes are 10 centimeters? Remember, one box is 2 centimeters, so 10 centimeters will be 5 boxes. So you start counting. 1, 2, 3, 4, 5. In this point right here is where you are going to locate the focal point. And you put it over there. Now, the other point that I'm curious of is my pencil P is placed 30 centimeters away. Okay, so how many boxes are those? 30 centimeters are how many boxes? How many square boxes?
15.
15.
15 boxes, okay? So I'm going back to my drawing and I start counting. Well, I know that this is 10. Remember? This one was 10. So 11, 12, 13, 14, 15. In this point right there is where my object is going to be located. Now, what I know about the object P? My object P is a pencil that is placed upright. So I'm going to start drawing my pencil. So my pencil is something like this. Trust me, it matters, okay? It matters how you draw the pencil because it says it's placed upright, okay? Now, now we need to focus on the this table right here. We need to look for the situation that we have. We have here 6 situations, okay? So we need to look for the position of the object. Take a look. My object, my pencil. What configuration does it have? Is it outside C? Is it located at the point C? Is it between the point C and F? Is it located over F? Or is it located inside F? What situation do we have? Number 2, number 3,
The
number
object
4.
is outside.
The object is outside C. Okay, so we are talking about situation 2. As you can see, it is similar, okay? This is your point C, and this is my point C. It's after P, okay? This is my point F, and this is my point F. So this is the situation that we have. So what we do is we follow the steps, okay? This table includes the steps. The steps that you will draw the lines. So we're gonna focus on the first step, okay? It says that it's coming from the tip of my object, from my tip of my pencil, horizontally until it touches the mirror and then bounces back, passing through the point F. That is very important that you see how the rays are moving, okay? So it says from the tip of my pencil to my mirror, okay? And then from my mirror passing through the point F. Okay. This should be a very very well drawn. Okay. I'm gonna change the color of this. Because I don't care. In this moment, I don't care about it. So this is your point. This is your first step. Okay. The first ray. Now the second ray. Take a look. The second ray. It is coming from the tip of my pencil, passing through the focal point until it reaches the mirror, and then bounces back horizontally. That is the second ray. I will imitate the same thing. Take a look. I'm using colors because I don't want to get confused. I suggest you do the same way. So it passes through the point F. Okay. Está bien. Okay. And then it bounces back horizontally. So I do the same way. Okay. This is my step number 2. So I put my second ray right here. And now my other point, my number 3, my point number 3, my ray 3, let's see, take a look. It comes from the tip of my object, passes through the center of curvature, touches the mirror, and bounces back in the same direction. Okay? So I'm gonna do the same. From the tip of my object, passing through my point C. I use yellow for this one. Now take a look. And then as I told you, it comes back in the same direction. That one doesn't really matter, so I'm gonna leave it there. This is my third ray. Okay? Now take a look. There is a point where the 3 lines intersect. And that point is right here. Okay? This point right here. So that point over there is what we know as the point Q. Okay? This is the point Q. And the point Q is the point Q, sorry, is the one of the one where the image is placed. Now let's take a look to the magnification. What do we know about the image? The image is located 15 centimeters away. So it should be 7 boxes and a half. 1, 2, 3, 4, 5, 6, 7, and almost a half. So we did it right. And about the image, it says real and inverted. So my image will be upside down. And because it's 0.5 less than 1, this tells me that the object will actually look smaller. So I'm going to place my object, my image, right there in this point, in the same way that the object told you. That is upside down. My pencil is upside down. Okay. And also, as you can see, it's also going to be reduced. Okay, that's my pencil. Now, how do I know if it is reduced? Take a look at the size of the original pencil, the real pencil. Okay, this one measures 4 boxes. Okay, in the image, it measures only 2 boxes. So, with this, we can confirm the magnification. The object is half, the image is half the real object. And this happens to be exactly like we said at the beginning. This one measures only 2 boxes, exactly half of the original object.